Today I am continuing the numerical problem related to the chapter force in motion, but at this time we are focused on the gravitation. I want to recall the Newton's law of gravitation, which was done in previous class. According to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It was done in previous class, and if you remember, this is the formula which is derived from this Newton's law of gravitation. Now, have you noticed that according to this law, actually, the gravitational force between two bodies depends upon their mass and distance. That's why remember this, gravitational force depends upon the mass and distance. Today I am going to focus on the relation of the gravitation with mass and distance with the help of some numerical problem. Look at this numerical problem. What will be the change in the gravitational force between two bodies when one of the mass is doubled? Yes, let's say this diagram represents the mass of two bodies m1 and m2, and they are separated by a distance d. The same we can write this way. Let mass of two bodies are m1 and m2 separated by the distance d. We are going through solution. Now, according to Newton's law of gravitation, what is the gravitational force between these two bodies? The same which I told you just before this slide, F equal to g m1 m2 by d square. Yes, it's very simple. When one of the mass, let's say it is m1, is if doubled, according to question, one of the mass is doubled. For better understanding, I am making diagram. Actually, in examination, we don't have to make diagram. The first diagram or second diagram, both the diagram, we don't have to make in the examination. Just the solution of the numerical problem is sufficient. Look at this. M1 is if doubled. Now, it is not M1, 2M1. Although remains same, then what will be the effect on gravitational force? The gravitational force cannot be represented now by F. Let's say it is F nu, and this is equal to G, and in place of M1 I am writing what? 2M1. Yes, it is double, and M2 remains same, D remains same. The same can be written like this. It means new gravitational force is 2 times G M1 M2 by D square. It means 2 times F. So, we can write this way, comparing equation 1 and 2. F nu is equal to 2 times F. Yes, what it means? It means new gravitational force between them is 2 times old gravitational force. This is the solution. Now, let's have another question related to the mass again. When the mass of both the two bodies are doubled, what will be its effect on the gravitational force between them? Let's say we have two masses m1 and m2 separated by distance d. The same is written in sentence. Now, according to Newton's law of gravitation, the gravitational force between them is F equal to g m1 m2 by d square. Till now, the same thing. When both the masses are doubled, then instead of writing m1, I have to write now 2m1. Instead of m2, I am writing 2m2. It can be understood nicely with the help of this diagram. M1 is made double, M2 is also made double. Then new gravitational force will be, instead of M1, 2M1, 2M2. Now 2 multiplied by 2 becomes 4. That's why F nu is 4 times G M1 M2 by D square. It means F nu is 4 times the previous gravitational force F. So we can say, comparing equation 1 and 2, F nu is equal to 4 times F. And what is our conclusion? Therefore, new gravitational force is 4 times greater than the old gravitational force. Okay, till now I told you about the mass. What about the distance? Let's have one question related to distance. What will be the effect on the gravitational force between two bodies if the distance between them is doubled? This is the diagrammatic representation. M1, M2 and their distance is d. The same can be written this way. The same thing I am repeating. According to Newton's law of gravitation, gravitational force between them is just g m1 m2 by d square. We know this because the same is done in previous numerical also. Now, when the distance between them is doubled, now it can be represented diagrammatically like this. I want to tell you again that diagrammatic representation is not necessary in the examination. This is just for you. I want to make you very clear about this. Okay, M1 and M2, the distance is no more d, it is now 2d. distance is doubled. Now what will be the effect on gravitational force? Now F new gravitational force will be m1 same, m2 same, distance is 2d and it is a square. It means what? F nu equal to g m1 m2 by 4d square. 2 square means 4. If 4 is taken at this place, we can write this way: 1 by 4th of the previous gravitational force. That's why comparing equation 1 and 2, new gravitational force is just 1 by 4th of the previous, just the quadrant. That's why we can write new gravitational force is quadrant of the old gravitational force. Okay, let's have another also. What will be the change in the gravitational force between two bodies when the distance between them is halved? Now we are decreasing distance. In previous numerical we increased the distance. Now distance is halved. This is, let's say, the distance between them d. First mass is m1, second mass is m2. Same can be written this way. The same thing is repeating, m1 m2 separated by distance d. According to Newton's law of gravitation, gravitational force between them is g m1 m2 by d square. Now what we are doing with the distance? Distance is halved. This can be understood with the help of this diagram. Previous distance was this much, let's say, and it is just halved, means half d. m1 remains same, m2 remains same. Distance is just half of the previous. It means new gravitational force can be written this way: as g remains same, m1 remains same, m2 remains same. D is halved, means d by 2, and 2 square means 4. Now F nu is equal to g m1 m2 by d square by 4. 4 goes up and we can write this way. Now new gravitational force is 4 times greater than that of the old gravitational force, isn't it? Comparing equation 1 and 2, F nu equal to 4 times F. It means new gravitational force between them is 4 times old gravitational force. In this class, I told you the relation of gravitation with the mass and distance in terms of numerical problem. Okay, now I want to stop now. We'll meet in another class.